All right, to name an ionic compound, you have to name the cation and then name the anion, and that's the name. So simple. It can be simple without being easy, so this takes a little bit of practice. First thing, when you look at a formula, you have to make sure that you can identify that it is an ionic compound and not a molecular compound like we talked about in section 6.1. Then the next thing you have to determine is whether the cation is a predictable metal or a variable metal. So we'll go ahead and fill out this column first. I'm going to do up to this one here, and then I'll scroll up and do the second half of the table. If it's predictable, we're just going to name that cation as the element. If it's variable, we need the element name and a Roman numeral. So we have to figure out the charge and get the Roman numeral. Then the anion is named with an IDE ending if it's a single element. If it's a polyatomic, you need to know the name of the polyatomic. So first let's go through and figure out which of these compounds have predictable metals. These are already all ionic compounds. We know that because we're in the ionic compound section. So we'll answer whether the metals are predictable or not. Magnesium is predictable, so is calcium, so is zinc, gold is not, silver is, and potassium is. So a lot of these are predictable metals. We can just go ahead and name them fairly quickly. So we name the cation after the element. This is just the magnesium cation. And then the name of this anion, it's a polyatomic anion and it's named sulfate. So this one is magnesium sulfate. This one, the calcium ion, is just named calcium, and this ion is nitrite. It's not nitrate, it only has 2 oxygens, so it's nitrite. This one, the metal cation, is zinc, and the anion is chlorine with a charge, which becomes chloride. So this is zinc chloride. Here we have gold, but this is not a predictable metal. So we are going to have some Roman numeral in parentheses. I'll leave space for that. We'll figure that out afterwards. And then nitrogen, when it becomes an ion, is nitride. All right, let's just keep going with these other two, and then we'll come back to gold. This one is silver, which is predictable, so we just call it silver. And this is nitrate. And then this one is potassium. And phosphorus with a charge becomes phosphide. So these are all named except for this one. Gold nitride is not the correct name. We need a Roman numeral. Nitride, we know, has a -3 charge. So our total negative charge in this compound is -3. So that means our total positive charge has to be +3 to make this an overall 0 charge compound. We have 1 gold and we have a +3 charge. So we take the +3 charge, we divide it by our 1 gold, and then we know that there's a +3 charge per gold. So this must be gold with a +3. And then you can double check putting gold with a +3 with nitrogen with a -3. Does that work? Yes, it does. So this must be a +3 charge gold. So we call this gold 3 nitride. Let's continue with the end of the table. I'm going to go ahead and add an additional compound just because I want to illustrate the difference between CuBr and CuBr2. All right, so first we are writing whether it's predictable, and then this one is the name. Since our column headings are missing, copper is not predictable, neither is titanium, neither is lead, neither is manganese. Magnesium is, but manganese is not. Cadmium, however, is. So let's go ahead and do this one first. This will be the easiest one. We have cadmium, and then this is nitrate. The rest of these we are going to need some Roman numerals. So this is copper something bromide. This is titanium something oxide. This one is lead with a Roman numeral sulfate. And this is manganese with a Roman numeral oxide. Let's do these two first. Okay, so maybe it's becoming clear why we need these Roman numerals, because if we just said copper bromide, we don't know which of these two we would be talking about. What we need to figure out is the anion that we have, the total negative charge that we have, the total positive charge that we have, and then we're going to divide that total positive charge by the number of cations that are carrying that positive charge. Here we have a bromide ion. There's one of them, so the total negative charge is -1. That means for a neutral compound, we need a total positive charge of +1. There is one cation carrying that +1 charge, and so this must be a copper with a +1 charge. A copper with a +1 paired with a bromine with a -1 would give a neutral compound. So since this is copper with a +1 charge, that's the Roman numeral, whatever that charge is. So this is going to be a 1. Here, this is the same anion, but there are two of them. So let's draw two. We have a -2 charge. That means we're going to need a total +2 charge. We have one cation, one copper atom to carry that charge. So this is copper with a +2 charge. And this would be named copper 2 bromide. So this one is copper 1 bromide. All right, let's see if we can fit this on the chart itself. So we have two oxide ions. So this is a -4 charge altogether. So that means we need a +4 charge. We only have one titanium, so this is going to have to be titanium with a +4 charge. So this will be titanium 4 oxide. 4 is written with an I in front of a V, the Roman numeral. So this will be 4. Here we have two sulfate ions. Each of those has a -2 charge. So we have -4 altogether. So this is very similar. We need a +4 charge. We only have one lead. So this has to be lead with a +4 charge. Here we have one oxide ion, a total of a -2 charge. So we need a +2 charge. We have one manganese. So this must be manganese with a +2. So we'll call this manganese 2 oxide. I want to give another example where we have more than one metal cation carrying the charge so that we can figure that out as well. Let's try this one. Now we have more than one cation. All of these had one cation, so we haven't seen any examples where we have to divide by the number of cations here. So this is going to be nickel, some kind of Roman numeral, and then oxide. Our anion here is oxide with a -2 charge. There are 3 of them, however, so we have a total negative charge of -6. To balance that, the nickel needs to have a total positive charge of +6, and that +6 is carried by 2 nickel atoms. So if the +6 charge is carried by 2 nickel atoms, each of these nickel atoms must have a +3. So we have 2 nickel atoms with +3 each. We have 3 oxygen ions with -2 each, and so that is how it is balanced out. Since +3 is the charge, we call this cation nickel 3. So this compound would be nickel 3 oxide.